Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. Sorry, it's Vitamath 16. I hope that this can help engineering students, high school students who plan to take up engineering in their studies. Two chords AB and CD intersect at point E such that AE, which is 8 centimeters, while AB is 12 centimeters. Chord CD is the longest chord of the circle, and segment CE is 7.5 centimeters. What is the area of the smallest region of the circle bounded by the segments of the chords and the arc of the circle? So to help visualize the situation, let's have the figure. So this is the circle, and let's draw chord AB and the intersection with the other chord AE, CD rather, is at point E, and this is the longest chord. The longest chord in a circle is the diameter of the circle. So let's label the given information such as AE, which is 8, EB, which is 12, one segment of the longest chord CE is 7.5 cm, and we will call ED the other segment of the longest chord or the diameter as D. Then we apply the principle on intersecting chords as the product of the segments of one chord is equal to the product of the segments of the other. That is 8 times 12 equals 7.5 times D. And after that, we locate the center of the circle and notice or observe that this is the smallest segment bounded by the segments of the chords and the arc of the circle. So if the center is somewhere here, that area is area of sector minus area of triangle. So 8 times 12, 8 times 12, the product of the segments of one chord is equal to the product of the segments of the other chord, 7.5 times D. So D therefore is 12.8 cm. Therefore, 12.8 plus 7.5, that would be 20.3 centimeters, which is greater than AB, the other chord. So this CD indeed is the longest chord, and it is 20.3 centimeters greater than 20 cm. Otherwise, the problem is wrong. So 2r, the diameter, is twice the radius of the circle. It is equal to 7.5 plus D. 7.5 plus 12.8. So 20.3 divided by 2. So the radius of the circle is 10.15 centimeters. So let's locate now the center, which is at O. And that's the radius, OA, 10.15. And we have a very narrow triangle. The angle, we will call that theta, and the distance EO is equal to radius minus 7.5. So let's call the angle also of AOC as theta. So EO equals 10.15 minus 7.5, so EO is 2.65 cm. So that in this triangle, OAE, we can compute theta by cosine law. Opposite of theta is 8, the other adjacent sides 10.15, the radius, and EO 2.65. So by cosine law, 8 square equals 10.15 square plus 2.65 square. Then this is the area of the smallest segment. We'll call that area S, which is area of sector AOC minus area of triangle AOE. So area S equals area of sector minus area of triangle, and I'm referring to triangle AOE. The area of the sector is 1/2 the product of the radii, or 1/2 radius square 10.15 square times central angle theta. While the area of the triangle is 1/2, remember, 1/2 product of adjacent sides 10.15 and EO, which is 2.65 sine of theta. Where area of sector is 1/2 radius square times central angle theta, theta should be expressed in radians. So 8 square cosine law equals 2.65 square plus 10.15 square minus 2 times 2.65 10.15 cosine of theta. So I hope that as an engineering student, you now know the cosine law and you can recall it. So solving for theta using your calculator, 2.65 square plus 10.15 square minus 8 square divided by the quantity 2 times 2.65 10.15, then the result inverse cosine theta is 31.137 degrees. Since for the area of the sector we need to convert that to radians, so we multiply pi times 100 pi over 180 degrees, and it is in radians equal to 0.54344 radians. We then solve area S. So area S is 1/2 times 10.15 square times 0.54344 minus area of triangle 1/2 times 2.65 10.15 sine of 31.137 degrees. So using the calculator, area S is equal to 21.04 square centimeters. So to reinforce the concept and the idea, I want you to solve this as your part, the area of the biggest region. So for your part, what is the area of the largest region bounded by the segments of the chords and the arc of the circle? So you just analyze which one is the largest, this or this part. So it's up to you. As long as you can show that the area is equal to, I'll give you the answer. Area of that biggest part is 140.8 square centimeters.